Hello everyone, welcome to this video. In this video, we are going to learn about MLP using OpenMathAI. So, let's get started. What is MLP? Multi-Layer Perceptron is a supervised machine learning algorithm based on artificial neural networks, used for both classification and regression problems. Unlike decision trees, random forest, and light GBM, which learn using decision rules, an MLP learns by adjusting the weights and biases of interconnected neurons through backpropagation and gradient descent. It consists of an input layer, one or more hidden layers, and an output layer, allowing it to learn complex nonlinear relationships between input features and the target variable. MLP starts by assigning random weights to all neuron connections. During training, the input features pass through the hidden layers, where each neuron computes a weighted sum, applies an activation function, such as ReLU or sigmoid, and passes a result to the next layer. The final prediction is compared with the actual value to calculate the error, and the weights are updated using backpropagation and gradient descent. This process repeats for many iterations until the prediction error is minimized. Imagine we want to predict a student's final exam score using features such as study hours, attendance, previous score, assignments, sleep hours, practice tests, internet usage, stress level, IQ score, and motivation. The MLP initially make predictions with random weights, then continuously updates them after each iteration to reduce errors. Over time, it learns the complex relationships between the features and produces highly accurate predictions. We will use this dataset for MLP model. So, let's get started. OpenMathAI. In this demonstration, we use the score prediction using MLP model. Click Create New Project. Enter the project name as Score Prediction. Choose a folder location to save the project, then click Save. To import your dataset, either click Load Example Dataset or browse for Dataset to import your own CSV file. Once the dataset is loaded, verify that it contains all columns before proceeding to model training. Scroll down to view the first 10 rows of sample data. Click Continue to Configuration to proceed. Configure the dataset by specifying the input features and output target. There's also a feature called Ignore, which can be used for columns that should not participate in model training. Select the input and output columns manually, or use Smart Suggest for automatic recommendations. There's a one more feature signal diagnostics. There's a 3 columns. First one is column. It tells which features are in the dataset like inputs and outputs name. Second one is VIF. It tells how much correlation of the features. Third column is status if it's okay, moderate, high, redundant, and constant. Review the selected configuration. Click Proceed to Model Design. Choose a model from the available machine learning models. OpenMathAI recommends suitable models and features based on the dataset. For this demonstration, select the MLP model. View the model overview, pros, cons, and real-world applications. Click Proceed to Training. You will see the selected model. Click Start Train Models. Review the training configuration. Test data split, which determines the percentage of data reserved for testing and validation. Review the model parameters and pre-processing settings. And also another feature is added that is trained from scratch or continue from use model. If you train this model before you use that option. Modify the configuration if required. Click Start Training to begin the training process. After training is complete, review the following performance metrics. R-squared measures how well the model explains a variation in the output data. Range 0 to 1. MSE, mean squared error, measures the average squared difference between actual and predicted values. RMSE, root mean squared error, the square root of MSE. RMSE is expressed in the same units as the output variable, making it easier to interpret. Engine time, the time required for the generated model engine to execute and produce predictions. Lower engine time indicates faster model execution, which is important for embedded systems and real-time applications. Fit quality, an overall assessment of how well the model fits the dataset. It is generally derived from metrics such as R-squared, RMSE, and residual errors. Model accuracy, For regression models, accuracy is commonly estimated using the R-squared value. Example, R-squared equals 0.95, accuracy almost equal to 95%. Click Fit to Window, you will see three types. Fit to Window, comfortable, compact. Then the Clear History if you click that it will clear the history before its trained model. Another is Deselect and select all trained models for export. Click View Curves. You will see the diagram of R-squared residuals and residuals diagram. Click Math and Code Preview to view the mathematical model generated by OpenMathAI. The preview displays the feed-forward neural network architecture, input, hidden layer, output, the mathematical equation for each layer, including weight matrices, bias terms, and activation functions, the generated source code, implementing the trained MLP model. A detailed explanation of how the neural network transforms inputs into predictions. Open the Math view to visualize a complete MLP computation graph. Maximize the Math view window and scroll down to see the layer-wise mathematical mapping from input to output, the training loss curve, which shows how the model's error decreases during training, the network structure, including input features, hidden neurons, activation functions, e.g., ReLU, and output layer. The visualization illustrates how the MLP combines input features through weighted connections, nonlinear activation functions, and multiple layers to learn complex patterns. After training, OpenMathAI uses the learned weights and biases of the neural network to predict outputs for new input data without retraining the model. Return to the results page and click Deploy Status. Click Export Model. Choose the required export format. Answer C. FMU 2.0, FMU 3.0, Verilog RTL, VHDL RTL, Python Bundle, ONN XHub. You can choose any of these format and export. You can also download the free trial versions of OpenMathAI and Twin Simulate. Thank you. Stay tuned for more OpenMathAI demonstration.